Hey there. Back again. Got a video here that I want to talk about. And, well, it's a video on YouTube. It's actually of a segment from the TV show Ask This Old House, which is the companion show to PBS's This Old House. In this segment of Ask This Old House, their home technology expert, Ross Trethui, went to help on a little trip to help a homeowner troubleshoot and upgrade their Wi-Fi service in their house. I thought this was a really good segment. A lot of good information here, but there's a lot of things that I just wanted to review it and give my 2 cents as somebody who, as you probably know, has worked in the industry and worked in a internet support call center for many years and helped customers install their Wi-Fi, set up their Wi-Fi, troubleshoot their Wi-Fi. And I also worked with Wi-Fi issues with my own service and other people that I know. So I thought this would be something fun to do here. So, without further ado, let's get started. And I am going to be stopping this. I'll try to keep it, not make this run out too long, but I will be stopping to give my opinions here and there, give my 2 cents.
Hey Ross, how you doing?
How you doing?
How you doing?
So I heard you have a Wi-Fi problem. Tell me about it.
So we're in the house for about a year now, and ever since day one, it's awful. The Wi-Fi keeps dropping, it's buffering. Wife's a teacher, so the remote learning is tough. Streaming for the kids, very tough.
Not the first time I've heard that. You know, any Wi-Fi network, any Wi-Fi system is only as good as its weakest link. So the service comes into the building, goes through a modem, then goes to a router, and then it broadcasts throughout the house. So I think it first starts with taking a look at where the service comes into the building. You know where that is?
Yeah, it's down in the basement.
All right, let's take a look.
Good point here. We'll start with troubleshooting the basics, the connection itself, where it comes in. Make sure we're not missing something. So look at, the cables and all, where they come into the house and where it goes into the modem. And he's obviously got a cable service, as you'll see. Not that it really matters.
I think that's it there.
Yeah,
Ooh,
I think
amplifier.
you're right. So this white wire, this is the input. So this white wire is the internet service provider's cable coming into the building. And that's actually going to the input channel of this amplifier. And that's a really good thing, because what I normally see is a bunch of these. That's a splitter. Right, so your internet service comes in and it splits to all different devices, and sometimes there's a lot of these. And the thing is, each one of these cuts the signal in half. So we want to reduce these, and you don't have any, so that's a good thing, okay? So from there, this amplifier is actually amplifying the signal coming in.
I just want to pause real quick. Yeah, I like how they've got the, it's obviously a professional install, because the techs always install the amps, and they've got the little caps on here on the unused ports to prevent signal leakage and stuff and dirt from getting in. And that black cable just beside his hand there, to the left of his hand there, that looks like it goes down to the one he was pointing at. That looks like it goes to the power supply, which you saw plugged in down below the wall wart.
To all the devices. It's going to the cable box, it's going to the modem. This device does require power, it is plugged in here, but the next thing is to figure out which one of these goes to the modem. So do you know where your modem is?
I think it's above our head.
Okay, so if you can go upstairs and do the tug test and just pull on the wire, and I can see if one of these is actually connected directly to it. If not, we'll do a continuity test. Okay?
No problem.
All right, sounds good.
With fancy equipment, you could always, tone out the lines and determine which line cable it is that way. But if you don't know, then something like this, you can, tug on it's fine.
Okay, Eamon, give it a shake.
I'm guessing the router was on the floor.
Got it.
Now he's,
Okay.
when he was on the table
Coming
before,
up.
now he's moved the table out of the way.
All right, Eamon, we verified that the wiring coming into the building and the wiring to your modem is good. All right, the next thing to check is placement. Okay, you can see here in the corner on the first floor, this is not the best location to be broadcasting Wi-Fi for your house, right? We'd rather see, if I didn't recommend nothing else, we move this to a more central location in the building, okay?
Good.
But before we do anything like that, I want to take a look at the
Not always
specs
feasible.
on this system. Okay, so this is a combination modem router, and it's rated for up to 600 megabits a second. Now, did you do your homework and bring a cable bill?
I want to stop right there. Okay, it's a combination modem router, or AWG as it's the technical term, Advanced Wireless Gateway. And he said it's rated for up to 600. Big asterisk there. What it's rated for per the manufacturer, i.e. what it's been lab tested for, and what an internet service provider will provision it for, big difference. A lot of that comes down to DOCSIS. DOCSIS, data over cable system interface specification. Basically, it's the protocol by which internet data travels over coax cables to a modem. So, DOCSIS modems, cable modems, have, depending on their design, they'll have a certain number of channels available, certain number of DOCSIS channels, and it depends on how many channels are available and on a given router, given modem, and how the ISP is willing to divvy those up. How much the modem can speed the modem can actually handle. So, what the manufacturer, in this case looks like Netgear, says on their packaging and their advertising, that's all fine and good, but that doesn't necessarily, and usually just straight up doesn't equate to what your internet company is going to actually allow to run on that modem.
I did.
Okay, what are you paying for speeds?
I can't tell.
Saying up to 200 megabits.
Okay, so you're paying up to 200 and your modem is rated up to 600. So the good thing is you don't need to upgrade your modem. We're good with that size.
Should I get an upgrade on the service?
You don't really need to do that either. Well, for your needs, 200 is more than enough, okay? So the next thing is we're gonna test how fast you're getting actually out of that modem. And for that, I'm gonna grab my laptop. All right, so the first test we're gonna run is a hardwire test. So I'm gonna take my laptop out and I'm gonna hardwire an Ethernet cord. So I'm gonna plug into the Ethernet port on my computer. I'm gonna plug into the modem directly. And what I'm effectively doing is I'm taking the Wi-Fi out of the equation. What I wanna do is get a theoretical maximum for what this system and what the network can deliver, okay? So let's run that speed test. Okay, you can see the speeds right there, around 150, 160. So that is the speed right now at this moment in time as we're doing the test. And that's going to change. It's going to fluctuate over time. So it depends on how many people are actually on the network at that moment in time. And you can see we're at 170 for our average download speed at this moment in time. That's.
I don't like to contradict them, but over wire, you should be seeing the full speed, period. You should be seeing that full speed, that full 200 or whatever. The fact that he's not, it's not hugely off. But the fact that he's not might say something there. And it's not going to be how many people are on the network at a time. That's not a factor on wired. Wireless, yes. Wired, no. You should always be seeing your full speed. I have 400. If I ran my speed test right now, I would, on this computer that I'm recording this on, which is wired, I would get 400. Full stop, I would get 400.
It's a really good speed. So the next test we're going to run is we're actually going to disconnect from this, and we'll do 3 Wi-Fi tests. We're going to do one on each floor. So one in the basement, one on the first floor, one on the second floor. And we'll see what we get. All right, so let's do a Wi-Fi test here on the first floor, so we're close enough to the router. Okay, and once we run that speed test, let's see what we get. Okay, we're right around 100.
Okay, that's not too
So the
bad
first
for
floor Wi-Fi
Wi-Fi,
test is
to be
coming
honest.
out at 96.
Is that good?
Yes, 96 megabits per second is a really good speed for normal internet activity, right? So video conferencing, emailing, streaming a video, that's totally fine. That's actually a good speed. So let's head upstairs and we'll do the same Wi-Fi test. All right, let's run a speed test. Okay. If you remember, we were 96 downstairs and we are at 40 megabits per second upstairs. Of course, we're farther away from the router, so it has, the Wi-Fi signal has to get through more building materials like the flooring and the drywall. And there's also, a little bit of interference that can be occurring from baby monitors and other devices, microwaves, for example. I did run a Wi-Fi analysis, and the good thing is you don't have any interference from neighboring networks. You're in a single-family residence, you're far enough away. But if you were in a multifamily, apartment building, you definitely would want to check your Wi-Fi signal and what channel you're running on. So let's get downstairs to the basement and we'll do the last test.
Okay. So this is the basement. That's where we spend a lot of the family time, movie nights, watching the game. Can't get through one show without buffering, without dropping signal.
That's frustrating.
I've gone upstairs to reset the modem. and still no good. So I went out and bought an extender. Didn't help any situation.
Yeah, so extenders put up their own Wi-Fi signal, but they still have to communicate to the router. And if you have a really bad router signal getting down here, guess what? It's going to cut your signals further in half. So it's not a great solution, especially for a wireless version. Let's see how bad it is, though, okay?
Wow.
Okay, so you're at 16 megabits
Nice.
a second. You were at 96 on the first floor. You were 40 on the second floor. You're 16 down here. To put it in context, 16 is good for like email and basic internet tasks. It's not really going to do much if you're trying to stream high-def video. Definitely not going to cut it. So the good thing is I have a solution. I'm going to go into the truck and grab it. I'll meet you upstairs. And for now, you can get rid of that Wi-Fi extender.
Perfect.
Okay, let's take a pause here. I'm glad that he showed testing it on multiple floors to illustrate the whole range for expecting speed. Thank you. Now, Wi-Fi, the science behind that, a little bit of science here. So Wi-Fi signal, as I've tried to explain to people many times, the Wi-Fi signal, well, one, it's a radio signal, as he mentioned, like any other radio signal. So things that will affect radio signal will affect it, obviously. But you also have to look at the way the signal broadcasts out, the shape of the signal. Wi-Fi signal is shaped like an umbrella, right? Like your umbrella, like that. The signal travels out, covers much better outward, horizontally, than it does vertically. And yes, definitely, and I'm glad he mentioned it, but yeah, definitely also has a lot of, lose a lot of the signal going upstairs or downstairs in the house. Wi-Fi just, again, by its nature, does not travel, the signal does not travel very well at all between the floors of the house. It just doesn't. Another thing I want to mention, and he didn't mention this really, although I think he does coming up, but the different Wi-Fi frequencies. So there's your 2.4 gigahertz and your 5 gigahertz, and newer Wi-Fi I know has 6 gigahertz. And a lot of people don't understand the difference, the 2G and 5G. So your 2G, your lower frequency, that's your older standard, goes back to the beginning of Wi-Fi, has good, decent distance, pretty good distance, but it tops out at a theoretical about 70 odd, like 72 megabits. Generally, I've seen less though in practice. Your 5 gigahertz and also your 6, they can go a lot faster. But because they're higher frequencies. But because they're higher frequency, they attenuate faster. In other words, they don't travel as far, so a lot shorter range. So that's a big range versus speed trade-off there. That's something they didn't mention. I wanted to throw that in. So let's continue here, see what solutions he's got for the homeowner. Alright, for a demo demonstration here, got my laptop here. I'm going to run a quick speed test. Just use Ookla speedtest.net, that's fine. And I'm just going to run a speed test just to show what we're looking at over Wi-Fi here. Okay, 50, 60, 60 odd, good, good, good. 63, 64. Okay, now it's going to run the upload. Just for full disclosure here, I have a basic internet service of 400 megabits down by 10 up, wired. And there we go. So Wi-Fi I'm getting, and I'm in the same room as the router. I'm getting 63 down by 10, 11 up. Okay, now that's on the 2 gigahertz. So let me switch real quick to the 5 gigahertz frequency. And then I'm going to run the same test again. Nothing has changed. I've just switched to the 5 gigahertz. Wowza. Look at that. Blazing. 174 down. Not shabby at all over Wi-Fi. And it's still going to be about the same up. That's not going to change. Yep, 11 point something up. So, the 5 gigahertz. Now, if I got further away, like even out of this room, I would start to drop signal completely. And start to lose. That speed would go way down. If I was with the 2 gigahertz, if I stayed on the 2 gigahertz, I would be able to maintain that 60 odd 60 odd megabits down a lot longer, a lot further away. Now it stopped at around 65 because that's actually the theoretical maximum for or right around the theoretical maximum for the 2 gigahertz frequency. Technically it's 72 in lab tests, but 65 is generally about the most you're going to see in practice. So that should give an idea of the difference between 2 gigahertz and 5 gigahertz. Now back to the video.
All right, Eamon, I think I have the solution to your inadequate Wi-Fi coverage. It is a mesh network, okay? These are called satellites. They're like Wi-Fi routers. There are going to be 3 of them. One installed here, one installed upstairs, one installed downstairs. Each one of these goes for $100 to $200, okay? The way these work is that they actually broadcast on 3 antennas. So it puts out a 2.4 and 2.5 gigahertz networks. What that means is that you have an extra channel. Right now you have a 2.4 and a 5. This gives you an extra one, okay? It's also Wi-Fi 6, so it has a lot of cool features that are going to give you better signal and better coverage, okay?
Okay, I need to stop there for a little clarification. Good, he's using a mesh system and he got rid of the extenders. I have a little sticky wicket here with how he described that. 2.4 and 2.5 gigahertz. Yes and no. Yes, there are 2.5 gigahertz frequencies that broadcast off of that main router and the access points. However, you don't have 2.5 gigahertz channels. So what you've got is your main Wi-Fi, your 2.4 and your 5 gigahertz and 6 if it's Wi-Fi 6 potentially, and then you have a dedicated 5 gigahertz connection that's just used for the connection between that main router, this new main router that he's putting in here, and the extenders, or not extenders, excuse me, between this new main router, I stand corrected, between this new main router and the access points. It's a dedicated 5 gigahertz connection. It's called backhaul is the actual term. Which, because it's 5 gigahertz, now you do need to be mindful when you do a mesh system where you're placing the router and the access point units, the satellites, as he called them, in relation to them, so you're not too far away. Otherwise, you're kind of defeating your purpose. Also, just something I want to throw out here real quick. Since he's putting that base unit for the mesh is a router, that modem, that black unit there is a modem router all-in-one. We already established that. It doesn't mention it here, but I'm hoping he went into that and put it in bridge mode. That is, basically turns the router, the built-in router, off, so that if he's going to have this connected to this new unit connected to that way he doesn't have a router on a router, because that could cause some other weirdness that you don't want to get into.
The other thing that we're going to install is a UPS. Okay, this is an uninterruptible power supply. So it's as simple as a battery with surge protection. So what's great about this is that if you lose power, you're going to have all the devices that are connected to it running on battery backup. So this is going to give you Wi-Fi coverage and extend your network for up to 6 hours during a power outage. It also has a little cell phone charger or USB charger, so you can charge some devices off of this as well. It also has surge protection. So if there's a signal that comes through from the utility and it creates a surge, this is going to protect those devices. Okay, so we're going to extend that over here. I've actually installed one already downstairs for the amplifier, but by plugging this in here, I can then now plug the modem into this UPS. And now I can install the actual Wi-Fi network, the first satellite. So this is called the main satellite or the main router. We're going to power it up, plug it in, connect our network. So this is the Ethernet cord, RJ45, that's going to connect to the back of the modem. We turn on the UPS, and that signal is going to go live. All you need to do is download the app, set up your Wi-Fi name, the password, and make sure you set up your security. And while you're doing that, I'm going to go upstairs and put in the second satellite upstairs and the basement one as well. All right?
I'm going to pause here real quick. Good, yeah. So this is a great, perfect use case for a mesh system. He's using Eero, which is a good brand. There's other ones. But yeah, this is a really good use case for it because you're covering multiple floors. He's already got the more or less ideal setup that his the modem and main router are going to be on the first floor, so it's centrally located as is feasible, and then cover the other floors with the meshes. Now, if you had a bigger space and you're using more mesh units, and this is where the mesh part comes in, that backhaul I mentioned, that connection between the satellite units and the access points and the main router, well, those satellite units not only talk to the main router, they also talk to each other, hence the mesh. And something else I want to mention real quick, because I didn't earlier, the difference between mesh units versus extenders, because he had a little extender downstairs earlier and that wasn't doing a lot of good. The best way I could describe that is, if you go back to my earlier analogy, my earlier umbrella analogy, right? Your extenders, each put out a little umbrella. It's just like a little bit of coverage, right? A smaller umbrella versus the signal that the router itself puts out. The mesh units, the mesh satellite units that he's got there, they put out their own. They each put out their own umbrella the same size as that of the main router. It's equal. Also, mesh units are designed to where they and the main router actually function together as one network, logical network. So the network name and all of that is one network. Makes management a lot easier versus an extender where you can go into the router, you can see the devices on the router, but not what's connected to the extender. A mesh, one thing, you can see everything. Simplifies things a lot.
All right, Eamon, did you get the Wi-Fi configured?
Yep, all configured.
All right, awesome. Now the moment of truth. Let's do the speed test.
Wow.
All right, 241. I'd say that's quite an improvement. Let's head upstairs. Run that speed test. If you remember correctly, we were at 40 before. Okay. And look at that, 235.
Nice.
Okay, let's head to the basement. We'll do the last speed test.
All right.
Moment of truth.
Final test. Here we go. So if you remember correctly, we were at 16 before, and look at that. We're at 183 megabits per second. That is blazing fast, okay? You're gonna be able to watch all the videos you want. You're not gonna have buffering. You don't have to go upstairs to reset the modem anymore. And really the power of this mesh network is that all those satellites work together to strengthen the Wi-Fi coverage across your house. So the last test, let's set up and run your TV. Okay, the TV's configured to the network. Leaving you with one of my favorite shows. I think you're in good shape.
Thank you for your help.
Thanks for watching.
Okay, yeah, he had a lot of good points there. A lot of good points. A few things that I had to add in there. And I know some of it, they just don't want to get too technical. I get it. But yeah, a lot of good points there on this episode or this segment. Good troubleshooting methodology. I liked a lot of that. I wouldn't really bother with the UPS unit. Yes, it's nice to have, but it's really not necessary, especially Wi-Fi. I wanted to say, if your power's out, then power's probably out in your area if it's a storm, and in that case, the ISP's equipment is probably going to be out of power as well, and so it doesn't matter if you got power to your modem, it ain't going to work. So that's kind of a non sequitur, but also beside the point of this video. Now, I want to look. I actually looked up the router, the modem router unit that they were showing, the AWG, the original Netgear, and I think this is the one. Rated for 600, DOCSIS 3.0, okay, 2-in-1. I just want to see the specs real quick. Okay, technical specs. Here we go. Built-in 8x4. You'd be hard pressed to get more than 200. 3 maybe, but that's pushing it really. I really don't see how they can possibly say 600 on that. I'm just not seeing it. Yeah, compatible with Cox Internet. I don't know what internet he's got there, but compatible with Cox up to 150. Yeah. Honestly, if it was me at this point, especially, I'd look at getting a newer modem just to make sure you're future-proofed. But yeah, I know there's a lot, and just to say, I know there's a lot of, how could I put this, misconceptions with Wi-Fi, and people expect too much of their Wi-Fi. In my years working in the call center, that was something I encountered an awful hell of a lot, was people expecting too much out of their Wi-Fi. And some of it was what they were misled in advertising, some of it was just general misconceptions. And I'm glad they showed a house in the video. I'm glad they showed a house with 3 floors, because it's a good use case for a mesh and why you need a mesh in a situation like that. The one Wi-Fi signal is only going to cover so much. It can only cover so much. So in something like that, yes, you would need an additional source of that signal on each floor. In this case, is preferred to get the best signal that you can get. If you were being cheap, you could probably get away with just one mesh access point instead of 2, but I would go with the 2 just to make sure you got good coverage on all floors, especially if you're using it equally on all floors. See anything in, that's yeah. Is there anything else I wanted to know about that router? 2 gigabit Ethernet ports, not really a point when you can't get gigabit internet, I guess, for connection between between computers on the network. Not that it matters. Anyway, I'm trying to think of other misconceptions of Wi-Fi. Distance and range. Speed. People expect it. I'm paying for X speed, so I'm going to get X speed all the time with my Wi-Fi, and that's not, as we mentioned here, that's not how that works. You're going to get what, there's a lot of different things that can affect Wi-Fi signal. A lot of considerations. Distance, obviously, range, as was mentioned. Are you on the same floor or not? How far away from the router are you? Where is the router located in relation to the other items that you're connecting with? Interference. I'm glad he mentioned interference. Ross mentioned interference. Neighbors, and yeah, you don't have any neighbors around, so that's good. Especially like you said, if you're in a multi-family situation, God help you, because everybody has their own Wi-Fi now, and they're all on the same frequencies. Trying to think of others. Speed. Also, another thing that can limit your Wi-Fi performance, and this is not one a lot of people think of, the device itself that you're connecting with may or may not be, fully capable of higher speeds. It depends on the Wi-Fi capabilities of that device. Is it capable of Wi-Fi, 5 gigahertz. What flavor of 5 gigahertz is it? Is it only Wi-Fi N, which is one standard? Is it the later Wi-Fi AC, which can get higher speeds on 5 gigahertz? Is it 6? Is it, there's lots of different variations of Wi-Fi, lots of different things to keep in mind. So every situation with troubleshooting Wi-Fi is going to be a little bit different. And that was how my years working in the call center, that's how I always approached those situations, those troubleshooting calls, is each one's a different situation, depending on the factors with the customer's particular setup and situation, what devices they were using, how many devices, all these different things, the type of equipment they've got, all of it. But on the whole, I think Ross did a really good job with the video, and I appreciated it. I liked seeing what he did with it to show the basics of how to troubleshoot a Wi-Fi issue. Since that's something that's so prevalent now, it needed to be shown. So kudos to this old house on this one. And I think that's about all I've got. So till the next time, whenever that may be, peace out.